When we ask, why is the speed of light so fast, we're already making a subtle mistake. The question assumes light is racing, straining, pushing itself to move faster than everything else. But that's not how nature works. If there's one thing Richard Feynman would insist on, it's that we must first examine the question before we chase the answer. Light isn't fast in the way a rocket is fast. It isn't accelerating, competing, or trying to win a cosmic race. The speed of light is not a performance, it's a rule. Imagine you're watching a game of chess. You wouldn't ask why the bishop moves diagonally, so aggressively. It moves that way because that's the rule of the board. In the same way, light moves at its speed because that is the rule of the universe. It's not that light has some special engine. It's that reality itself is structured so that this speed, about 300 million meters per second, is woven into its fabric. This is where we have to shift our thinking. We're used to asking what causes something to move. A car moves because fuel burns in an engine. A plane moves because air flows over its wings. But when we talk about light, we're not talking about an object being pushed. We're talking about something that emerges from the electromagnetic structure of space itself. The equations of electromagnetism, the ones discovered in the 19th century, already contained this speed before anyone understood what it meant. The number was just there, like a hidden signature in the mathematics. It wasn't chosen. It wasn't adjusted. It simply appeared as a consequence of how electric and magnetic fields interact. That's astonishing. It suggests that the speed of light is not about light at all. It's about space. Space is not empty nothingness. It has properties. It allows electric fields to exist. It allows magnetic fields to exist. And when those fields ripple together, that ripple moves at a speed determined by the very nature of space itself. Light is simply the visible evidence of that ripple. So when we say light is fast, what we really mean is that the universe has a built-in conversion factor between space and time. And here's where it becomes philosophically profound. This speed, this constant, doesn't depend on who measures it. Whether you're standing still, running toward the beam, or racing away from it, you measure the same value. That defies our everyday intuition. If I throw a ball from a moving train, its speed depends on how fast the train is moving. But light refuses to play by that rule. The universe bends space and time themselves to protect this speed. Distances contract, time slows down, not because light demands it, but because the structure of reality requires consistency. Think about what that means psychologically. We grow up believing time is absolute. Seconds tick the same for everyone. Distance is fixed, space is rigid, but the speed of light quietly tells us that those assumptions are illusions. Time can stretch, length can shrink. The deeper truth is that what we call reality is more flexible than our senses suggest. Light exposes that flexibility. This is why the speed of light is so fast. It isn't competing with anything. It defines the maximum rate at which cause can become effect. It defines how quickly information can travel. It draws the boundary between what can influence you and what cannot. In that sense, it shapes the visible universe. Every star you see, every signal you receive, every interaction between particles is governed by this limit. And notice something subtle. Nothing with mass can reach that speed. The closer you try to push something with mass toward it, the more energy you must pour in. Its resistance increases. It becomes harder and harder to accelerate, as if the universe itself is saying, this far and no further, not because it's cruel, but because consistency demands it. If massive objects could cross that boundary, cause and effect could reverse. the logical order of events could collapse. So the speed of light is not a number sitting in a textbook. It is the skeleton key of physical law. It connects electricity, magnetism, space, time, causality, and energy into one coherent structure. It tells us that the universe is not a chaotic accident, but an ordered system with deep symmetry. And perhaps the most humbling realization is this: light isn't extraordinary for moving at that speed. Everything else is extraordinary for moving slower. Light simply moves the way the universe allows motion to exist at its most fundamental level. When you truly grasp that, you stop asking why light is so fast, and you start asking how profound it is that reality has a limit at all. The speed of light is not about motion. It is about the architecture of existence. And once you see that, you begin to understand that the boundaries in nature are not obstacles. They are the very framework that makes meaning possible. The speed of light is not racing through the universe. It is revealing the design of it. Now, once you accept that the speed of light is not just a fast thing, but a fundamental rule, the next step becomes unavoidable. If that speed is built into reality itself, then reality must adjust to preserve it. And this is where the story becomes truly unsettling and beautiful. When Albert Einstein took the constant speed of light seriously, he didn't treat it as an experimental curiosity. He treated it as a fact about the universe that must be true for everyone, no matter how they move. And once you make that decision, something has to give. Either the speed changes depending on who measures it, which experiments show it does not, or space and time themselves must change. This is the moment where intuition breaks. In everyday life, we assume time is universal. 1 second for me is 1 second for you. We assume length is fixed. A meter stick is a meter stick, no matter how fast it's moving. But if the speed of light is constant for all observers, those comfortable assumptions cannot survive. The universe preserves the speed limit by reshaping the very stage on which motion happens. Move faster through space, and you move slower through time. That's not poetry. It's measurable. Astronauts traveling at high speeds age slightly less than people on Earth. Particles accelerated in laboratories live longer than they should. Time itself stretches. It becomes elastic. And psychologically, that's a profound shock, because time feels absolute. It feels like the one thing you can trust. You might question memory, perception, even identity, but you rarely question time. Yet nature tells us time is not a rigid river flowing the same way for everyone. It's intertwined with space, forming a single fabric, space-time. Think of it like this. Imagine you're moving through reality at a constant total rate. Part of that motion is through space, and part is through time. If you increase your motion through space by moving faster, you must decrease your motion through time. The total remains balanced, anchored by the speed of light. You can't exceed that balance. The universe enforces it. This is not science fiction. It's geometry. Space-time has a structure, just like a sphere or a saddle has structure. And the speed of light acts like a boundary in that geometry. It's the line that separates what can influence you from what cannot. Events outside your light cone are causally disconnected from you. They cannot affect you yet. Reality is not just happening, it's unfolding within a structured web of possible influence. And here's where it becomes philosophically powerful. The faster you try to move through space, the more resistant you become to acceleration. Your mass effectively increases. Energy pours in, but instead of simply making you faster, it begins warping time and length around you. Clocks slow, rulers shrink. The universe doesn't allow you to casually cross the boundary into light speed because doing so would unravel cause and effect. Imagine if you could move faster than light. You could arrive somewhere before you left. Effects could precede causes. The logical chain of reality would snap. The universe would no longer be coherent. So space-time bends to protect consistency. It bends to preserve meaning. That should make you pause. We often think of physical limits as restrictions. But what if they are safeguards? What if the speed of light is not a barrier holding us back, but a principle holding the universe together? And this intertwining of space and time tells us something deeply psychological. The world is not built around our intuition. Our brains evolved for survival on a slow-moving planet, not for grasping cosmic geometry. So when relativity feels strange, it's not because it's wrong. It's because reality is richer than our instincts. Richard Feynman used to say that the first principle is that you must not fool yourself, and you are the easiest person to fool. Relativity forces us to confront that. It forces us to admit that what feels obvious may be profoundly incomplete. The speed of light ties space and time into a single fabric, and then demands that fabric remain consistent for all observers. That demand reshapes reality at high speeds. It reveals that time is not universal, that simultaneity is relative, that motion is woven into geometry itself. And once you see that, you can't unsee it. You begin to realize that certainty is fragile, that limits are meaningful, that the universe is structured not for comfort, but for coherence. Space and time are not separate backdrops. They are dynamic participants in every event. So, the speed of light is not just fast. It is the thread stitching space and time together. It is the principle that preserves order when motion threatens chaos. And if the universe is willing to bend time itself to protect a single constant, perhaps the lesson for us is this: the deepest truths are not the ones that feel intuitive, they are the ones that remain consistent, no matter how hard reality pushes against them. Respect the constant, question your intuition, and be willing to let your understanding stretch, because growth, like space-time, only happens when you move beyond what feels fixed. Now, after we've seen that the speed of light is woven into the structure of space-time itself, the next question becomes even more interesting. Why is light the thing that travels at that limit? Why not something else? Why not a rock or a spaceship or you? The answer takes us into the nature of mass and into something surprisingly simple. Light has no rest mass. That sounds technical, but it's actually a profound statement about freedom. When we talk about mass, we're not just talking about weight, we're talking about resistance to acceleration. Mass is what makes it hard to push something faster. The more mass something has, the more stubborn it is about changing its motion. It resists. If you push a bicycle, it moves easily. Push a car, it takes more effort. Push a mountain, and you'll be there a long time. That resistance is mass. Now imagine something with zero rest mass, not small mass, not almost nothing. Zero. What would it resist? Nothing. Light more precisely. Photons do not have rest mass. That means they don't sit still. They cannot be at rest. The very concept of a photon standing still doesn't make sense within the laws of physics. They are always in motion, and not just moving at the one speed spacetime allows for massless entities. This is not because light is powerful, it's because it is unburdened, and here we see something elegant. Massive objects can approach the speed of light, but the closer they get, the more energy is required. Their inertia increases. From the outside, it looks as though their mass grows. You can keep pouring in energy, but instead of crossing the boundary, the object becomes harder and harder to accelerate. It's as if nature is tightening a leash. Why? Because to reach the speed of light, a massive object would require infinite energy. And infinite energy is not something the universe hands out casually. So the speed limit of the universe isn't enforced by a wall. It's enforced by geometry and energy. The equations quietly say, if you have mass, you cannot reach that speed. If you do not have mass, you cannot move any slower. It's a beautifully clean division. Now this connects directly to the work of Richard Feynman, especially in quantum electrodynamics. Feynman helped us understand light not just as a wave, but as particles, photons interacting with charged particles like electrons. These interactions obey precise mathematical rules, and within those rules the masslessness of the photon is not decorative. It is essential. If photons had mass, even a tiny amount, the structure of electromagnetism would change. The range of forces would shift. The stability of atoms might be altered. The universe as we know it, chemistry, biology, stars, could be radically different. The fact that photons have zero rest mass is not a minor detail. It is foundational. But let's pause on the philosophical side. Mass represents attachment. It represents resistance. The more mass you have, the more anchored you are to certain behaviors. You cannot instantly change direction. You cannot casually accelerate. You are constrained. Light, in contrast, is pure motion. It doesn't carry the burden of rest. It doesn't hesitate. It doesn't need to be pushed into action. Its existence is movement. There's something psychologically powerful about that distinction. Everything in our everyday experience is massive. Everything resists change. We feel that resistance in our own lives, habits, fears, inertia. Change takes energy. Growth takes effort. Acceleration demands fuel. Physics mirrors that truth. To move faster through space, when you have mass, requires enormous energy. And the closer you get to the ultimate limit, the more unforgiving the demand becomes. So when we ask why light is so fast, the answer is almost the reverse of what we expect. It's not that light is extraordinarily driven. It's that it has nothing holding it back. It exists at the natural pace dictated by space-time. Massive objects, including us, exist below that pace because we carry structure, complexity, and inertia. And that's not a flaw. It's simply the condition of being matter. The speed of light, then, is not a trophy for the fastest thing in the universe. It is the default speed of causality for anything unburdened by mass. It is what motion looks like when there is zero resistance from rest mass. And that reframes the whole discussion. Instead of asking why light is so fast, we might ask why matter is so slow. Because matter is bound, it is structured, it is tied into interactions that give it identity and stability. Without mass, atoms would not form. Without mass, you would not exist to ask the question. So the universe draws a clear line. Massless things move at the ultimate speed. Massive things move within it. The boundary is not arbitrary. It is a consequence of energy, geometry, and consistency. And once you see that, you realize something profound. Limits are not always about restriction. Sometimes they are about definition. Mass defines what it means to be matter. The speed of light defines what it means to be free of it. Light moves at the universe's speed limit not because it is exceptional, but because it is unburdened. And maybe that leaves us with a deeper reflection. In physics, as in life, what holds you back is not the absence of speed, it is the presence of resistance. So now we arrive at the final layer of this idea. We've seen that the speed of light is built into the structure of space-time. We've seen that space and time bend themselves to preserve it. We've seen that massless particles naturally move at that limit because nothing holds them back. But there's something even more profound here. The speed of light is not just a fast number. It is the speed limit of causality, when physicists write it as c. They're not just labeling a velocity. They're marking a boundary, the maximum rate at which information, influence, or cause can propagate through space-time. Nothing you do can have an effect somewhere else faster than that limit. No signal, no force, no interaction. And that constraint is what keeps the universe logically coherent. Imagine a universe without that limit. Imagine if information could travel infinitely fast. If that were the case, every event could instantly influence every other event. There would be no meaningful separation between here and there, now and then. The structure of cause and effect would blur. The universe would lose its local character. Or imagine something even stranger, faster, than light travel that allows effects to precede causes. In certain reference frames, you could send a message back into your own past. You could receive a reply before you sent the original signal. Paradoxes would not be philosophical puzzles. They would be physical realities. The consistency of events would collapse. The reason that doesn't happen is because the speed of light forms a boundary around every event, what physicists call a light cone. Inside that cone are the events you can influence and those that can influence you. Outside it there is separation, not because of distance alone, but because of the finite speed at which cause travels. This finite speed creates order. It ensures that actions precede consequences. It ensures that history flows in a consistent direction. It preserves the chain of logic that allows the universe to be intelligible at all. And here's something subtle but powerful. The speed of light does not merely limit motion. It defines structure. It shapes how galaxies form, how stars ignite, how atoms remain stable. The delay in information across vast cosmic distances gives rise to evolution, to change, to the gradual unfolding of complexity. If light traveled infinitely fast, the universe would be a rigid, instantaneous whole. If it traveled much slower, stars might not efficiently radiate energy. The balance is delicate. The constant C sits at the center of equations governing electromagnetism, relativity, and even the relationship between mass and energy, the famous equation E equals mc2. That equation tells us that mass itself is a form of energy scaled by the square of this cosmic speed limit. In other words, C is not just about motion. It is embedded in the conversion between matter and energy. It is stitched into the fabric of existence at multiple levels. This is why Richard Feynman approached constants like C with such reverence. Not mystical reverence, but intellectual respect. He understood that when nature repeats a number across different domains of physics, it is telling you something fundamental. It is revealing a deep symmetry, and psychologically, this has implications beyond equations. We often experience limits as frustrations. We want faster communication, instant results, immediate change, but the universe operates with a built-in tempo. There is a maximum speed at which influence spreads. There is a rhythm to causality. You cannot bypass it. Even light, the fastest phenomenon we know, takes time to cross a room. It takes over 8 minutes to travel from the sun to Earth. When you look at distant galaxies, you are seeing ancient history because information travels at a finite speed. The night sky is not a snapshot of the present. It is an archive of the past. That delay is not a flaw. It is what gives the universe depth. Without the speed limit of light, there would be no meaningful history, no unfolding narrative. Events would not cascade through time in a structured way. The limit creates separation, and separation allows development. So when we ask why the speed of light is so fast, perhaps we are asking the wrong emotional question. It is not fast in a competitive sense. It is precisely as fast as it needs to be to preserve causality, structure, and coherence. It is the guardian of order. The universe could have been chaotic, inconsistent, paradoxical. Instead, it is constrained by a constant that ensures logical progression. Every cause has a future cone of influence. Every effect has a past cone of origin, and C draws the boundary between the possible and the impossible. That boundary is not restrictive, it is defining, and maybe that's the lesson we carry beyond physics. Limits are not always barriers meant to frustrate us. Sometimes they are the very principles that make complexity, meaning, and growth possible. The speed of light is the universe's ultimate speed limit, not to hold reality back, but to hold it together. And if the cosmos itself is built on respecting its deepest constant, perhaps we should ask ourselves, what principles in our own lives deserve that same unwavering respect?